So let's look now at combining these transformations together. And our goal here is using all the information on reflections, expansions, compressions to transform a function. So nothing new in this section, just combining it all together. Remember, when we have a function, before we can transform it, we have to put it in a form that allows us to read it. So if we take our original function y equals f of x, the transform function will be a version of this with a's, b's, h's, k's, etc. Remember what they represent. When we have a reflection, that tells us that the a value, the b value is negative, or we have the inverse, a reflection across the line y equals x. That'll tell us it's a reflection. The important thing when we are doing our transformations is reflections will always be the first thing that we do. We always want to reflect first, especially when it comes to doing the inverse of a function. Well, after our reflections, then we can do an expansion. Remember, a greater than 1 tells us it's a vertical expansion, and a b that's a fraction tells us it's a horizontal expansion. We're looking for the a and b values. Then we did our compression, and compressions are when the a value is less than 1 and the b value is greater than 1, vertical or horizontal. And once we've done our reflections, expansions, and compressions, then we can do our translation, our moving up vertically with K, up or down, moving horizontally left or right with H. What is important about this is the order. Much like an order of operations, the order of the transformations is very, very important. The reflections, expansions, and compressions must come before the translation. And if you can remember that mnemonic, rect like rectangle, the reflections, expansions, compressions must be done first. The other way we can think of it is translations must be done last. However you want to do the reflection, expansion, compression, but make sure the translation is done last. Let's put it into practice like in this situation. Here's our point. Originally on our function y equals f of x, we're going to transform this coordinate following that indicated transformation. So our original point was at -4, 2, and we're going to work our way through and do this transformation step by step. First piece is the negative. Negative outside the function, that tells us that we are going to have a reflection across the x-axis. What does that do to our coordinate? Well, it takes the y coordinate and it's going to multiply it by -1. So let's do that transformation. X coordinate stays the same. The y coordinate becomes not 2 now, but -2. Well, let's continue on. What does the next value? Well, inside the function there, we have the value 1/3, 1/3. And that 1/3 inside the function is going to multiply the x-coordinate now by the reciprocal, 3/1. So really what we're doing is taking our x-coordinate and multiplying it by 3. That would change this -4 into a -12. Then let's look at our last value here, our +2. And what that +2 is going to do is it's going to take our y coordinate and it's going to add 2 to the value, translate it up 2 units. So how does that transform this point? Well, the x coordinate stays the same. We add 2 to the y coordinate and we would be at 0. And our final new location for our point P would be the coordinate -12, 0. Well, if we can do this with numbers, we can do this with a coordinate that has variables. So let's keep in mind, we first want to take our function and write it in a form that's easy to read So we can find the a, b, h, and k. We're going to factor out a -2. Just be careful in that factoring. That's going to leave us with -3 inside the function and then -5. And now we can read our h, k, as well as our a, b, and we can do our transformation. So we just use the rules we did as before. We start with the point AB, and let's do our transformation. Well, I'm going to do two transformations at the same time here just to speed up the process. That -3 tells us it's a reflection across the x-axis. It's going to change the y-coordinate, but it's also going to multiply that y-coordinate by 3. So as we get better and better at this, we can do that in one step. Multiply by -3. Same can be said for the next pieces. We have a negative inside the function and a 2. All we have to do is keep in mind we need the reciprocal when we're inside the function. So we're going to multiply our coordinate by -1/2 and carry the y as it was before. Now, once we've done the reflections, expansions, and compressions, now we can do the two translations. And again, we can do this in one step as we get better and better. We're going to take our x coordinate and we're going to now add 3 to it. And we're going to take our y coordinate and we're going to -5 from it. And there is our new transformed coordinate based on that transformation originally given on the function. Well, let's look at this if it's a graph, because we can do that same transformation to a graph. What we have to keep in mind when we see an absolute value is we're always comparing to our basic absolute value graph, which I'm just going to sketch on here. Remember our basic absolute value graph, every x value corresponds to the positive y value. We put our points and draw in the v, and there we go, our absolute value. So now what's going to happen when we transform this absolute value? Well, let's look at our first coordinate, 0, 0. And we're going to do this transformation of 0, 0. This is the coordinate 0, 0 right here, and we're going to transform it as needed. First thing we have is outside the function. We have a reflection across the x-axis and a compression by 1/2. So we would take our y coordinate, multiply by -1/2, but of course 0 times 0 is always 0. So our coordinate only gets transformed by moving it left and right and up and down, just translating it. So in this transformation, we're going to move this 3 to the right and 4 over. There's our new coordinate. We just take the point, go over 3, 1, 2, 3, up 4, 1, 2, 3, 4, and there's our new coordinate. Now we could do the calculations for each of these, but let's try and do this actually in our head to speed up the process. I'm going to choose the point 1, 1. There's our coordinate 1, 1. If we were to take the coordinate 1, 1, and as we transform it, let's do this all in one step. Let's take this point, and here's the original point. When we reflect it across the x-axis, it's going to end up here. Now we're going to take the y value and multiply it by 1/2. So instead of being at -1 in the y, it's up a little bit at 1/2. Now from this point, now we can move it 3 to the right, 1, 2, 3, and up 4, 1, 2, 3, 4. And here is our new transformed coordinate, our new point on our transformed graph. If you do need to write them out, feel free, but let's try the same now with this coordinate. We're at -1, 1. Reflection across the x-axis puts us at -1 in the y. Multiply by a half is going to put us at -1/2. Now we're going to take that coordinate and go over 1, 2, 3, and up 1, 2, 3, 4. And here is our new coordinate, just like that. Well, let's pull one that's a little further away. Let's try this coordinate right here. This coordinate is at -5, 5. So if we take the original coordinate, reflect it down 5, there's the reflection across the x-axis. Take that value, multiply by a half, so it's going to be at -2.5. Now we go to the right 3, 1, 2, 3, and up 4, 1, 2, 3, 4, and here is our new coordinate. Now we could use symmetry to find our other coordinates, but let's just do this one more time. The better we can get at doing this, the faster the process is going to be. So here's a coordinate. It's at +5 in the y, which means the reflection is going to put it down at -5. Cut that in half. It'll be at 2.5. Now we take our coordinate, move it over 3, and up 4, and there is our new point. Now, because we know it's an absolute value, we can just connect these dots and we'll get our new transformed function. And the better you can get at that, the faster the process will be for transforming any graph. So let's look at one last graph. This time we don't have an actual function, we have it in function notation, but the same principles can apply like we did before. We're going to take coordinates and we're going to transform them, and we're going to choose points that are easy to read on our graph, and we're going to do this transformation to these coordinates. So if we first look at the negative, that's going to take our coordinate and reflect it across the x-axis, which will put it here. If we multiply it now by 2, instead of being at -3, it'll be down here at -6. Now we have our translation, 3 to the left, 1, 2, 3, and our translation, 1 up, and there is our new transformed coordinate. So let's try it with this point. And let's now try and do this -2 in one transformation. The reflection puts it to here, multiply by 2, we're at this point. Now we translate 3 to the left, 1, 2, 3, and 1 up, which puts us right here, and there is that new coordinate. Let's go again with this coordinate. Now if we multiply the y value by -2, it'll put us down at -4. We go 3 to the left and 1 up, and we have our new coordinate. One last one, let's take that point, same thing, multiply by -2 will put us down to -4, over 3, up 1, and here is our new coordinate. And once we have our points transformed, we can now just draw our straight lines in, connect our points, and there is our new transformed function. And we're going to continue to do more of this combination of transformations in class.